Hello everyone, we're here to present our Kaggle project. It's a movie recommendation system. The presentation has 4 parts: analysis of data, k-means clustering, validation and testing for the algorithm, and at last equal test testing. The first part is the analysis of the data. We are using the movie database. It contains 4,803 movies, and it has 20 variables. And first is the histogram analysis. From this histogram, we can know that most of the movies in the dataset is in English. Only 7% of movies are in other language, like French or Spanish. However, the type for movies are widely spread. The top 2 types are drama and comedy, which means among the movie which has the type label, half of them are covered by these 2 kinds. Then we try to plot release dates of the movie, but the plot isn't satisfying because it contains not only years but also months and day. So we convert the date of the year, convert the date to the year so that it can plot more clearly. From the graph, we can see that most of the movies in the dataset are released around 2000. It means we have the data of the latest movies. And here we have a correlation heat map using numbers and colors to represent the positive or negative between 2 variables and how correlated they are. It's very clear that the vote count is highly correlated with revenues, popularities, and a movie with more budget would probably attract more audience and more likely to get success in the box office. In order to implement the algorithm, we want to choose number of parameters which makes sense, like ID numbers doesn't make sense, and the less correlated. So we choose release year, popularity, and budget to implement the k-means, and then use the vote average to select the movie to make recommendation.
And then let me introduce the k-means clustering. K-means clustering is one of the most commonly used unsupervised algorithm for partitioning a given data set into a set of k-groups. Since we have the data of movies, we have to use unsupervised algorithm to classify them. Here we've used the popularity, year, and the budget, and here is the data we used. And in order to define k value, we have chosen 3 different values for k. Here are the results of the program, and the first one is the result when k equals to 3, and these are the results of when k equals 5 and 7. But the problem is which one is the result we need, and the method of choosing k value is try to reduce the sum of squared error. The squared error, here is the formula of the sum of squared error, and here Ci is the ith cluster, and Mi is the center of gravity of the cluster, and P is the sample in the cluster. And as the number of clusters k increases, the sample partitioning will be more refined, and the degree of aggregation of each cluster will gradually increase. So the square of error and the SSE will naturally become smaller. So the result when the k equals to 7 is the result we need.
Compactness of clusters is also an important characteristic for cluster validation. Here it is calculated using the variance of the clusters. The algorithm with maximum compactness, which means the minimum average distance, is considered as better clustering approach. In this figure, we see the comparison of the compactness of clusters by the number of clusters. The results of this comparison show that we reach a minimum average distance with 5 clusters, which is a good choice for our k-means clustering method for our data. For the future observations, we applied the k-means clustering method with k equals 7 clusters. In this example, we want to recommend some movies similar to the movie The Dark Knight Rises. We found this movie to be in cluster 4. Then we recommend the 15 highest rated movies in cluster 4 and in the same genre using filters. A solution is to reduce the number of dimensions by applying a dimensionality reduction algorithm such as principal component analysis that operates on the 4 variables and outputs 2 new variables that represent the original variables that you can use to do the plot. In this other example, we did the same job. We found the movie The Aviator to be in cluster 6, and here are some similar movies.
Next, we will do some hypothesis testing to see if our recommendation system has a good effect. Firstly, we want to study whether the release year for the movie in the same cluster are close. So let S be the release year for the movie in cluster 5. The law per hypothesis is that S is a normal random variable with the mean of the cluster 5. And the alternative hypothesis is opposite. Using Neyman-Pearson, we compare the likelihood of two hypotheses. If their ratio is greater than a certain value, h, we will reject the null hypothesis. The average release year for all movies we can get is 2002, and the average release year for movies in cluster 5 is 1990. We find that the ratio of the likelihood is very small, so we can say that the hypothesis 0 is true. And then, using the t-test, we can test whether there is a significant difference between the two clusters. The results show that the release year for movie in cluster 4 and the movie in cluster 5 are significantly different, and the p-value is very small. Finally, let's look through our project from the beginning. Firstly, we prepare the library and the data, and then description and visualization of our data. And then our recommendation system by k-means with different value of k. And finally, hypothesis testing. Thanks for your watching.